Hey, go ahead, Mark. Go ahead.
Yeah, so I was gonna say I'm a big proponent of multi-tenancy in Kubernetes. I always have been. In fact, uh, Tremolo was a sponsor at the first KubeCon that was in Seattle in 2016, and that was when the expo hall was in the lobby of the Sheraton in downtown Seattle, and we had our little booth, and I had a Pi stack of our multi-tenant Kubernetes cluster, and people were like, "You're nuts! Why would you ever do this in a multi-tenant way? Just give everybody their own cluster." And at the time, OIDC was just barely working. RBAC had just been introduced. You didn't have network policies yet. You didn't have resource quotas yet. So there was some logic to why you wouldn't do multi-tenancy with Kubernetes in 2016. But in 2024, like 8 years later, tools are there. Scott, preach, right?
Yeah, you broke up a little bit on that last part, Mark, right before. But myself, yeah,
Oh
I've
no,
been
I
a
was saying
proponent.
preach, right? Like, you've got a little bit of experience with multi-tenancy, right?
Yeah, just a little, right? We've been doing that since day one. So we called it many years ago namespace as a service, right? I know you hear that term more now versus Kubernetes as a service. And it deals a lot with obviously resource usage, right? I mean, I've done the math on, you're spinning up all these clusters versus a multi-tenant. There's obviously some challenges with it. We can accomplish the majority of those challenges, you can accomplish yourself, minus what we're going to talk about in here, right? Stuff like a CRD or a cluster level operator, right? Or things that get a little bit more dangerous in a multi-tenant world. But you can tell multi-tenant is becoming much bigger, right? Because I didn't go to KubeCon EU, Mark, you were there, but from what I read, there was a day called Multi-Tenant Con. So all about dealing with
Yeah.
multi-tenancy. So it is kind of nice that I'm with Mark. About 5 years ago, I was told, you're crazy. I'm like, trust me, this is the way to do this. Kind of validation in a way to say, okay, cool. Maybe I was crazy, but not as much as people thought.
Yeah.
Um,
So for folks, the CRD is it comes a lot, at least in my conversations on Kubernetes controllers for testing controllers or upgrading controllers, and vCluster have come up in those scenario where things like a project called Crossplane is a project about creating controllers and creating new CRDs, and to the point that there's too many CRDs for a kube API server to handle. Like when you have too many CRDs, actually there was a performance bug in Kubernetes, and it got resolved to the point that you cannot. We're talking about thousands of CRDs, right? That was not intentional in Kubernetes to have so many types. That way, something like vCluster, seeing people do it, because then you get a second as an additional kube API server all by itself, right? Another etcd or another database. And some folks were using K3s with Kine. And that way, instead of using etcd, they're using things like an SQL database, like RDS, and they saw better performance that running SCD in a pod, for example. But yeah, CRD isolation is good also for testing. I've seen it a lot on using talking about the use cases for vCluster to move it a little bit along. But that's what vCluster gives you, right? A second kube API server.
yeah, the beautiful thing about vCluster is you get this little API server that runs inside of a container, right? And as far as your pods are concerned, it thinks it's part of the vCluster. So even though from a scheduling standpoint, the containers are still scheduled by the host cluster, the API server communications all happens with this virtual cluster. So if your workload has its own CRDs, and we walk through this in the chapter where, we actually see how vCluster overrides the DNS environment variables so that you're saying your pod thinks it's part of this virtual cluster instead of talking to the control plane cluster.
And the DNS is to when, for example, when a pod wants to talk to the kube API server, not that pod should talk to a kube API server, but you have something like a controller, right, that needs to talk to kube API server. It will look for a host. The host of that service is Kubernetes.default, right, .service. And instead of getting an IP address of the host kube API server, you get the IP address of the pod of the vCluster. Is that what the core DNS, the DNS virtualization does?
Yeah. So what happens is if you look at, sorry, I'm just adjusting my camera here a bit, so I'm not looking up at everybody. There we go. So what happens is when you look at the, I think if you scroll down a little bit, we actually show in the book how the DNS gets updated. But there are basically two primary components to the vCluster. There's the API server itself, and the API server. Yep, here we go. So we actually you can see where we're overriding the environment variables. So, or excuse me, vCluster. So vCluster is two components. It's an API server, three components. Excuse me. It's an API server, and that API server can be a vanilla API server that is running on with an etcd database. It can be a K3s instance, which is what we use in the book, and it's my favorite to use on top of MySQL, so that helps you centralize it. I think it also supports K0s, which is Mirantis's.
K0s, Kate's, and also OpenDistro EKS.
Yeah, although I think they dropped support for EKS.
Okay.
Yeah, I think they dropped that actually in version 0.2.
And Kate's ADM, kube ADM, right? They have Kate's.
Yeah, it'll do kubeadm, which is what the vanilla is. K0s and K3s are the big ones.
But it's these three pods running in a namespace, right? That's for vCluster running core
Right.
DNS. This is which are the last two? I'm trying to remember.
So the my cluster stateful set. So that's your actual API server and the syncer. Okay. So
the syncer.
The syncer. Yep. So
which one is the syncer? The last one?
No. My cluster -0 is a multi-pod.
Multi-container pod.
Set.
Yes.
Yep.
Oh, multi-pod. Okay, stateful set.
Yep.
Okay.
So one of the pods or one of the containers in the pod is the API server. The other container in the pod is your syncer. So when you create a pod inside of your virtual cluster, the syncer is what says, okay, I'm going, think of it almost like an admission controller. I'm going to rewrite that pod definition so that it can get scheduled by the control plane. But as far as the pod is concerned, it thinks it's talking to my vCluster -0.
I see. So the first two are when you deploy vCluster. Basically, the first two are vCluster. The last one is an example. Maybe.
Yeah, that's it. And quite frankly, even core DNS. I mean, that's just a pod running on the vCluster. That's it's the vCluster itself is my cluster -0. That's your vCluster. Okay. That's your virtual cluster. Core DNS runs as a pod on the vCluster. Virtual pod, and then virtual pod default, my vCluster. That's how the name gets mangled so that it can run and get scheduled in your control plane.
I see.
When you launch a pod in your vCluster, it's really being scheduled by your control plane cluster.
Yeah. because the pod, when you create a pod here, the real pod, I call it, the real pod gets created on the host cluster. And I was reading this week on vCluster, I found out that they have a new, I don't know how recent it is, but they have a new mode called multi-node, multi namespace mode, where now you don't those these pods, instead of being created in the namespace where you're creating vCluster, it can be deployed on any namespace, and they don't have to have the dash in front, like to namespace these
Oh,
things.
I've not played with
Um,
that yet.
Yeah.
yeah, and they have a new syncer called generic syncer, because I don't know if I have documentation for vCluster. In vCluster, the syncer only sync certain things, a very small set of of types, like an ingress, a pod, a service account. But if you wanted to sync, for example, a certificate for cert manner, or an issuer, or something custom, you have to create a plugin with Go. They have now a generic syncer. I think it's an experimental, that now you can state, when you deploy the vCluster, you can say, I want to import from the host maybe the CRDs, for example, and then deploy the controller inside the vCluster using the CRDs from the host. Um, and also the other way around, of like exporting from the vCluster to the host. That way now it's open to sync anything that you want. But yeah,
And
continuing on the
I want
multi-tenant.
to
Go ahead.
actually, sorry, Carlos. I actually want to. Alan asked a really good question about why vCluster has to support multiple distros. Um, and this is a common confusion point with vCluster. vCluster is a installation and management tool. It is not a cluster management. It's not a Kubernetes implementation. So when you launch a vCluster, the vCluster project is an installation and management tool. It is not itself a Kubernetes distro. You're still relying on some implementation of Kubernetes at that point. So from a project standpoint, it supports multiple implementations of Kubernetes because it can. Like that's just what it's designed to do. There was an attempt by, I think it was Alibaba, to create a more like unified virtual cluster where it was all in one thing. But I think it just lost steam. The whereas with Loft's vCluster project, what's really nice about it is, it's got that flexibility because, K3s or vanilla K8s is great if you have a way to back up all those etcd servers and you've got something in place to manage those etcd servers. I don't like that approach personally because now you have each vCluster has its own data store. In the book, we went with K3s because K3s works with MySQL. So when we get into the automation later in the book, we have one MySQL server. We can use Cert Manager to generate certificates so that K3s can talk to MySQL without a password and keep that up to date. And it all just magically works through the magic of Kubernetes and cloud native. But that's why it's supporting different distros, is that it itself is not a distribution. It's a management and a deployment tool.
So Mark, it might be important to kind of point out that there is, of course, open source vCluster, and they do have their enterprise offering, which changes their view a bit. So Loft does recommend in the enterprise one to use the full K8s, but they have a tool that can back up your etcds and that. And I did hear this morning they're considering dropping K0s on that. So it's going to be
too many things to maintain there.
Probably at that
for a
point,
small company. Actually, they got a investment the other day. So, but yeah, it makes sense. Like enough of a Kubernetes. Yeah, the binary of that this vCluster is running a container, and that container is it's the code from Kube API server, and that comes from K3s. Doesn't come from vCluster, or it can come from K0s. That binary. But the K3s is the most flexible one that people use for lightweight. I think SQLite. Is SQLite the default one when you deploy vCluster?
If you are not an HA, it's SQLite by default, and then If you want to use HA, if you want to have highly available,
Yep.
which we cover a little later in the chapter, you're going to need either MySQL. If you're using K3s, you're going to need MySQL or Postgres. If you're using generic, then it's just got K3s. And then one more thing on this point that I think is really important that the folks at Loft probably need to do a better idea of explaining or conversating is when you buy support for them, they're supporting vCluster. They're not necessarily supporting the virtual cluster itself, right? So like if you buy, so like let's say you're running EKS as an example, and you launch a bunch of virtual clusters using K3s.
Okay.
They're going to support you. Like they're a great company. They're going to do their best for you. But at the end of the day, you're still running an open source Kubernetes. You're not running you're not running the thing that you're paying for with DKS. And so that's just something to keep in mind when you think about vClusters is how to, if you're paying for support, you're a commercial customer, how does that play into it?
Oh, I didn't know. I thought they only had their pay offer SaaS thing. Interesting.
Mark, if I may ask to that last point, from your experience, or Scott, how many production environments have you seen running vCluster, in the wild? Is that it's been, and given that they have an enterprise support model, I would think maybe it's more prominent, or is it still fairly new?
I'll tell you, it's out there, Jack. I can't necessarily name some of the companies I know using it, but it's not like I don't believe you're not going to find tens of thousands of it yet, but it's now really gaining some steam, right? I don't know if it's from the add-ons or if it's from the fact of more people looking at multi-tenancy and saying, well, okay, I've got a application that, for an example, requires, of course, CRDs. Now, CRDs by themselves aren't necessarily a problem, right? But it might have an operator that's a cluster level operator.
Yep.
Right. And in which case now, do you want to delegate that authority to say another namespace and say, cool, look what you can do at the cluster level? You're probably not going to do that, right? If it's a CRD that does all namespace level stuff, like Redis can do something like that, that's a different story. But there's some, it might be a mutating webhook too, right? You're not going to delegate mutating webhook control to a normal developer namespace. So in that kind of an idea, like we do a lot of centralized Kubernetes management, my team would have to maintain that. We don't want to, right? Because it's a lot of stuff to maintain in snowflakes. You give them something like a vCluster, you can knock yourself out, right? And it just works in their vCluster. The pods run, like Mark was saying, on the host cluster. So you're still adhering to security policies and everything else. It's just, it does get confusing, right? You guys probably see this Russian nesting doll thing happening, right? Or it's like Inception, because you got something inside of something and you got to keep track of the clusters. There is that thing to get your mind around first too. But once you do that, it's really cool if you think about the ideas for it.
One thing that I want to point out, and it's a big, I can say because I have talked to many end users, I should be watching my language, end users that think that vCluster, and it's okay to have that misconception. I think I had at one point, and then when I found out, like, oh, it's only 2 pods. I thought it was like actual box that you put inside the other box. So going back to the multi-tenant, I think you covered this in the book. Going back to the multi-tenancy isolation type of thing. So if you have we go back to namespaces. You have an application in namespace 1, application in namespace 2. That's names 2 things in namespaces. When you start to isolate the IP address in Kubernetes by default, this pod can reach the other one if you don't do anything. So that's why you bring network policies. Also, the pod in namespace 1 and pod number 2 can land in the same worker node, same host machine, like namespaces. People think that by installing vCluster, that automatically the pods that are inside the vCluster suddenly their network is blocked. They cannot reach the IP address of another pod that is running on the host. And they also think that because you put a pod in this vCluster, it will not be able to run on the same node as a pod that is running on the host. And that's the big misconception I think a lot of people have, is not. The network access open. The scheduling of the pods that land the same node, same thing. So that this
So I'm gonna actually turn that on its
ahead.
head a little to say that that's actually a good thing. Because the flip side of that is any policies, any network policies, any quotas that you apply to your host cluster, you get with a vCluster.
Yep.
Right? You don't have to re-implement those in your vCluster. So in the book, as an example, when we onboard a tenant in chapter 12, I think, when we get to OPA and whatnot, where you're building out your policies for each namespace. When the pod from your vCluster gets scheduled, they're going to inherit all those policies. So if you've got a pod in a namespace, and let's say you just are using pod security standards, right? Pod security admission, and you have an unrestricted namespace, or you have I always get this backwards. You have a restricted namespace, right? That's the one where you can't do anything.
In enforce mode, yeah.
It's in force mode, right? Thank you. When it's restricted in enforce mode, in the parent cluster, the host cluster, I usually call it a control plane cluster, your virtual cluster pods are bound by that. So you only have to apply those policies to your control plane, to your host cluster. You don't have to now apply it to every single virtual cluster. So that actually, I think actually is a big benefit, is that you're able to inherit it rather than having to re-implement it on every single virtual cluster.
Yeah, and that's like what I was saying kind of too, Mark, right? So at the vCluster, you might give them the cluster admin, but they're not going to suddenly say, cool, I can run a privileged container, because that's going to go to the host cluster. And in a multi-tenant, I'm hoping you're blocking that, right? At least you better be, and a bunch of other things. But it's not going to work, right? So it does kind of throw that security model on its head a bit, because you kind of think, oh, the vCluster, they have cluster admin. Wow, this is dangerous. Not really, right? Depending. They could break something in their own little vCluster, but they're not going to bypass anything we set at the host cluster.
Yeah, the other really nice thing there is GitOps, right? Because you now have cluster admin access, you have this, Scott and I, when we were first playing around with this idea, we talked about ephemeral clusters.
Yep.
Where we said, all right, the entire, and I did a webinar with Loft on this, I think last year, where the entire cluster is disposable. Everything is managed by Argo and by your GitOps controller. And so you can give your tenant cluster admin without worrying about the I want to give them cluster admin except for the COOP system namespace or what. If they blow up the whole cluster, who cares? You shut the whole thing down, you rebuild it, and you drive it off of Git. It really gives you a lot of flexibility.
Absolutely. We have a hand up. As if we want to, is it Ashraf?
Yes, regarding multi-tenancy, actually, because I spent personally a lot of time in my work regarding multi-tenancy. So this is more or less sound like the hard multi-tenancy. So every tenant has his own cluster, in a way, virtual cluster, but his own virtual cluster. So that's similar.
Logically, yes. Yeah.
So that's similar, maybe, to HyperShift in a way as well from Red Hat. But the challenge will happen when you start to have soft multi-tenancy, where the tenants are all sharing the same cluster, as you said, Scott, the cluster admin access, when they want to make TCP dump. So we have a lot of challenges here regarding the tenant boundaries. So, for instance, sharing the same host or sharing the same worker would be a challenge to allow them to make TCP dumps, because that means tenants can see each other traffic. You have no more control on this. So these are the challenges which will have for soft tenancy, but for multi-tenancy, that I think is a good approach. But on the other hand, the overhead is a big regarding storage part, because if you want to share the storage, either you have to have it outside, so to have a share. But if you want to have a hyper-converged storage, then the overhead will be a big in case of hard multi-tenancy. That's my point of view.
It might be an interesting discussion to have, Ashraf. So on even on the soft, I've done presentations on this at Google Next, and that's my model, right? So we have big clusters with could be 700 namespaces, right? I know I've worked with other companies, DreamWorks, similar. It can be done, and it can be done securely.
Yep.
And vCluster is definitely not something that I think I would say go nuts on, right? 'Cause especially in enterprise, it costs money, first of all, right? It's got to be for the right reasons. But that's something I think it'd be an interesting topic.
My question was more around like the nature of the workloads being different, like one just designed to just coming back up and down and all the time, where you also try to host old school applications in containers. Would they work okay together?
From what I've experienced, honestly, they have, right?
Yeah.
So we do different workloads, definitely. And don't get me wrong, there's always reasons to do dedicated stuff as well, right? Especially if they need a lot of resources. You got an application that needs 30 nodes, you're probably not going to multi-tenant that application. But whenever I'm going to design something, right, I design everything tier 0. I don't really care what's running on it. So that goes to the availability kind of thing, Ashraf, that you're saying. And so even if you're on like a tier 2 or tier 3 service, you're getting the availability of a tier 0 service. It's just easier not to make snowflakes, in my opinion, especially at scale. But there's definitely going to be exceptions to workloads, right? I think that's definitely going to happen. But we got anything from monoliths, I'm going to call it, to poorly written, to pure cloud native. And they can exist. Resource usage is something you got to think about, especially with on-prem fixed infrastructure. You don't want to waste too much because there's probably chargeback models. Most companies do this, right? You got to somehow recoup this. It's hard to dynamically assign resources like that because you might run out. So it's a balancing act.
The on-premise is a different game. At least in cloud, what I've seen, people selecting to say, I'm not going to put these 2 workloads in the same cluster, going to choose to split them into 2 clusters, is when maybe there's 2 teams and one team is in charge of running stateful workloads like Elasticsearch, Kafka, database in Kubernetes, and they don't have the maturity to do upgrades. So it takes them like a year and a half to do an upgrade, where they decide not to put the stateless app with the databases. Then they decide to put like in one cluster to put the stateless apps, like the microservices that they're not running PBs or anything like that, in a different cluster. And then that one is an easier one to upgrade for that team, or just do a blue-green, like deploy the app, do a canary rollout, and then delete the whole cluster and then come, because there's no stateful state to manage. But the other team has Kafka running and is servicing a lot of business units, or they're running MySQL or Postgres. And then when it gets time to upgrade the cluster, because they're going to be force upgraded by the cloud providers do that. So upgrade your clusters. Then they're asking us, like, can you give us one more week, 1 more month? Like we're going to force upgrade you. So if you didn't back up those data, right, for your Kafka or your database, you never did an upgrade, you don't know how it works, then you're in trouble. But that's the only reason I've seen so far. Running on the host. And then this is important. the auth path for that specific vCluster. As you create multiple vClusters, they will have a different path in the same vault. For example, you share the vault on the host and the vault for the vClusters. And what is the cluster read for Hashi? Like this is annotations that are like handled by the mutation webhook, I'm guessing, right? To inject that init container or sidecard. Okay. And then cluster read, what is that role? That role is inside vCluster? Sorry, Vault. There's a role, there's
On the
annotation
screen.
that says role cluster read on the screen.
It's Vault.
Okay. So it means that this is just informational, like it's not enforcing, right? That you only have
No,
access to read
it's
keys.
enforcing.
Oh, this annotation. So if I go and change the annotation to cluster write, and suddenly this token is good to write keys into this path, suddenly?
I'm sorry, I'm not actually. Can you scroll down a little bit? I'm not seeing the whole thing that you're sharing. So, okay, so the cluster read is the name of the role that you're associating with inside of Vault. So if you change that to write, there is no cluster write role, so you wouldn't be allowed to. And even if there was a cluster write role inside of Vault, there's a policy that says which roles this token can use.
Okay.
So no, you can't just change it there and now be
So
able
it's just informational. I'm guessing this annotation.
It's not informational, no, because tokens can assume multiple roles. So
I see.
in this instance, we wanted to assume the cluster read role.
Assume cluster role. Okay, a cluster read role.
So in
you
theory,
assume
you
and then you
multiple
act.
roles.
Okay.
Right.
Yeah.
I'm sorry, I need to drop. I have a 1 o'clock
me too.
that I need to go to.
Oh, wow.
But if anybody wants to chat, I will be in Slack. So, but thanks for everybody, and Scott can.
Thank you everyone
That's very interesting. Thank you.
For coming, and I'll put my updates in the Slack, and
Awesome.
as I try to set it up. So I may just set up a VM in AWS and run the scripts for now. As we find the ARM60, I think it's good to look into what's not working in ARM64. So when Mark gets the operator for Open Unison, we can take a look.
Yeah,
but
definitely.
for now, we can use x86. Thank you so much, and come back next Friday. We'll have part 3 on the book, and in Slack, give feedback if you like the book, if you have any questions, and then also Mark is looking for the Discord. There's a Discord link that was not working. He's going to figure that out and post it in Slack. So thank you so much.
Thanks,
Thank you,
guys.
everybody.
You got
next
the
week.
chapter for next week?
See you next
Very
week.
good. Thank you.
See you next week. Thank you. Bye.
Does Carlos, you know the chapter for next week?
I was going to
Just
ask that.
Read in advance if possible.
I will ask Mark what we're doing
Okay.
next week. I'll put it in Slack.
You got it. Thank you.
Okay.
Yeah, I
Bye.
lost track. Thanks, guys.
Okay, watch
See you,
out
everybody. Have a good
for
weekend.
the next chapter. Bye.